Alright, so for our quiz this Friday, you're going to have to know how to look at a circuit and calculate the power for different components. So let's start off with an example. Say I give you a battery that has 12 volts. And of course, big side is positive, little side is negative. And suppose this battery is connected to a resistor here and a couple of resistors here and another resistor right here. Ooh, that resistor didn't come out looking so good. Let me fix that. So let me redraw that resistor here. So here we go. There's a better resistor. Alright. So you got these different resistors here. And suppose this one is 10 ohms. This one is 20 ohms. And we'll say that this one here is 30 ohms. This is also 30 ohms. And this one's going to be 60 ohms. So the question is, what is the power through the battery? We'll call that P-BAT for short. It's power through the battery. The first thing you might need to know is that power depends on current and voltage, and that's thanks to our P in the IV equation. And of course there's some variations on that. You've got the variation where there's only current and resistance, and also the variation where there's only voltage and resistance. So basically, if you can just find any two of these variables here, then you can use those to solve the power for the whole circuit. But keep in mind, if you're talking about current, it's got to be the current through the battery. And if you're talking about resistance, it's got to be the resistance, the total resistance that is working against the battery. So, you have to start off this problem by figuring out what is the total resistance in the circuit. And you have to start there because otherwise you can't even find the current. So if we're going to start with the total resistance, then we've got to know what, actually I'm going to keep these here. What kind of circuit is this? Well, you might look at this resistor and think, okay, so if you're a positive charge and you're moving, then there's only one way to go through that resistor, right? And that's true. Also, keep in mind positive charges don't move, but we pretend like they do. Anyway, however, if you're a positive charge and you come down to this point, well, now there's a couple of places where you can go off to the left, you can go down to the bottom, or you can go off to the right. And so that's not a one-way road. This is not a series circuit, not even a series part of the circuit. In fact, this whole section is parallel. So let's start off by solving this parallel part. You know that the equation for a parallel resistance is you have to add up the inverse of all of the resistances. So in this case we've got 1 over 30 plus 1 over 30 plus 1 over 60. Alright, so you work the problem, you solve it, you get 2 over 30 plus 1 over 60, which is the same thing as 4 over 60 plus 1 over 60. I'm going to continue my work down here just to give us a little bit more room. So this ultimately equals 5 over 60. Now if you solve for REQ, which you can do by cross multiplying, or you just flip both sides of the equation at the same time, well, this is going to give you 60 over 5, which is equal to 12 ohms. What we just figured out is that this whole section of the circuit, this parallel part, basically is the same thing as having a 12 ohm resistor. Okay? So that means I can forget about this jumbled mess inside of there and just pretend like that whole thing is a 12 ohm resistor. Okay, so let's move forward from there. Now we've figured out the resistance of the parallel part of the circuit, and we're going to pretend like that whole chunk is just one resistor. What's the next step? Well, you might have noticed that there are other resistors in series with this one. And so we can treat this circuit now like it is a series circuit. You've got our 10 ohm resistor up here, a 12 ohm resistor here, and a 20 ohm resistor here, and they are all in series. So to find the total resistance, oops, that's a mess. To find the total resistance, now for a series circuit, you just add up the resistances. Plus, let me do this without the units. 10 plus 12 plus 20. Okay, 10 ohm resistor, 12 ohm resistor, 20 ohm resistor. And we find that the total resistance of the circuit is 42 ohms. Are we done? No, because we're trying to find the power in the circuit. So, at the very least, we found something quite useful, which is our equivalent, or rather the resistance for the whole circuit. But we also know the voltage that is applied to this whole circuit, and that's 12 volts. So basically, we don't even need to find the current. I mean, you can if you really want to. It's, V equals IR, I equals V over R, and in this case that's 12 divided by 42, which gives you a number. I'm not going to calculate it out right now. But my point is that we can use the REQ, the equivalent resistance of the circuit, and just the voltage, and go straight into solving the power for the circuit. So let's do that right here. Power is equal to V squared over R. And V is 12, got to square it. R is 42. And so basically we are dividing 144 by 42. And when you do that, you calculate that the power is it's actually 3.428. I'm going to round it to 3.43. And what are the units of that? Hey, what are the units of power? Oh, that's right, watts. Oh, good one, Mr. C. Well, congratulations, folks. We just figured out how to solve the power for this entire circuit. So we would say that the battery is supplying 3.43 watts of power to the circuit. And that's how you solve that kind of problem.